So now, before going to start any mathematical calculation, it is very important for you to understand the complete design process of a plumbing system in a flow chart or in a uh, single line method. So basically, when we talk about design of plumbing system, it means calculating the diameter, calculating the size of all the pipes which are involved in water supply plumbing system. So during the design process, it is our duty to find out the dia of or pipe size of water distribution pipe, water service pipe, and water supply fixture pipe. We have this formula to calculate the dia. Here V is the water velocity, Q is the flow rate, and D is diameter. You must know these two unknowns to find out the value of dia. Okay, so how we can calculate the value of flow rate and velocity? This is the main question. Let's look over here. Our purpose is to design plumbing system by calculating the pipe size or diameter of a pipe. So to find out the pipe size or diameter, you already know from this equation that you require Q over here, Q and velocity, these two things. The input for pipe calculating the pipe size, there are two inputs. Number one is water demand, which is also called Q, and the units are GPM. And number two, second input is velocity. Okay. Now the second question is how you calculate water demand. You can calculate water demand by calculating or by measuring the water supply fixture units. You cannot calculate directly GPM, or you cannot take the values of GPM from International Plumbing Code. Okay, so the first thing is you must know the water supply fixture units of the entire building. You can convert water supply fixture units into water demand or GPM. So this is the first method, okay, for measuring your first input. Now for velocity, you must consult ASPE handbooks, American Society of Plumbing Engineers handbooks. The handbooks provide you the values for the velocities. If you use copper pipe, the velocity value is different. If you want to use plastic pipe, PPR pipe, then the velocity values are different. So these values are basically uh, you can say that you can get these values from these handbooks, and normally these are these velocity values are as good engineering practice. Okay, so this was the complete design procedure. You can draw this chart in your notebook, or you can take a screenshot of this chart. We will follow the same path. First we calculate the water supply fixture unit in our sample example, and then we can get the velocity value from ASPE handbooks. I will provide you all the velocity values, okay, in this course in the upcoming lecture. So you don't need to worry about it, that you don't, if you don't have these handbooks, no need to buy these books. Okay, I will provide you in this course. So by knowing the value of velocity and water demand, you can put these two values in and you can calculate easily. I know this is little bit confusing thing, but for right now, just the purpose of this lecture to provide you a complete overview of the design process. We will solve and learn how to use this equation in the upcoming lecture. Now let's discuss about the estimating water demand, or in other words, estimating the GPMs, like how much number of GPMs gallon per minute required for a residential house, or a villa, or you can say in a high-rise building. So to calculate the amount of water required in a building, we have a widely acceptable method which is called Hunter's method. It was proposed by Dr. Hunter in 1940s, and therefore it is widely used by most of the companies and adopted by different international standards like International Plumbing Code, Uniform Plumbing Code, and ASHRAE handbooks. There is another method proposed by American Water Works Association in early 1970s, but that method is not used by different designers. Most of the people, you can say, rely on Hunter's method because it is widely acceptable and adopted by different international standards. So my course is focus on this method, right? I will teach you Hunter's method to calculate the water demand, and we follow this method to design our plumbing system. So guys, in this video we will estimate the water demand in easy words, GPMs of a residential cold water system. Here we have a sample project, or you can say a sample example of a residential house. In this house, we have a ground floor and we have a first floor. This is main supply line from water municipality. This blue line represents the supply of cold water system to the building or to a residential house. On the ground floor, we have a kitchen sink. KS represents the kitchen sink. We have water closets in a washroom. WC, water closet. We have a lavatory. Lavatory represented by LAV. On the first floor, we have lavatory, we have water closet, and one bathtub. All right. This main supply line, as you know that right before entering into the building, this section is called water service line or water service pipe. Inside the building, the entire blue line of pipe represents cold water distribution system. As this pipe supply only cold water, therefore this pipe represents the cold water distribution system, and this one is cold water service pipe or line. The green pipe represents the pipe which connect this branch pipe with the fixture, and this pipe is called water fixture pipe, right? So this is our a small project, and we will solve or you can say we design the pipe of this sample example. Just to avoid confusion, let me clearly you one thing. To find the GPM or to find the estimation of water demand, or you can say to find water demand, the first step is water supply fixture unit. To find out the water supply fixture unit of each fixture. Okay, you cannot calculate direct GPM of any fixture. You can say this fixture require 5 GPM or this fixture require 10 GPM. It's not like that. Okay, we developed a new unit in plumbing systems or in plumbing engineering, which is WSFU, water supply fixture unit. First we calculate water supply fixture unit. We will add all the water supply fixture unit of these three fixtures. Don't get confused. I will teach you everything from where you get the values of water supply fixture units, WSFU. Right now, just I'm giving you an overview. Okay. The first step is calculation of water supply fixture unit. We will add all the water supply fixture units. Okay, after addition of the water supply fixture units, we will convert the WSFU to GPM. Okay, in the upcoming video I will elaborate this thing to avoid any further confusion, and we will solve and we calculate the dia of these pipes. All right, so see you in the next video. Now let's discuss about water supply fixture units. So prior to sizing a domestic water system and determining pipe sizes, it is important to understand the concept of fixture units. Water supply fixture units, WSFU. WSFU is the standard method, right, for estimating the water demand for a building or any residential facility. Now this system is assigned an arbitrary value called WSFU to each fixture, either it is water closet, laboratory, kitchen sink, all the plumbing fixtures. So when we assign a value to each fixture in a building based on the amount of water required and the frequency of use, let's learn with the help of an example. A WSFU of water closet in a private project like in a residential house, the value is 2.2. These values are taken from IPC, International Plumbing Code. I will show you the table from where I get this value, right? So water closet is assigned a WSFU of 2.2, while a sink or a lavatory is assigned 0.7 fixture unit FU. These values I already told you based on International Plumbing Code, right? Let me show you. Page number 152, Appendix E, table number E103.3 bracket 2, right? In this table, there are the list of fixtures that required in a plumbing system: bathroom group, bathtub, bidet, kitchen sink, drinking fountain, urinals, washing machines, three types of washing machines, water closets, public and private. We further classify the occupancy in two categories: private, offices, or public, right? So in our example, we have taken water closet 2.2. So this is water closet, this is private. So in private, we have two options: flushometer valve or flush tank. It means there is simple water closet with a flush tank, right? 2.2 value. Normally in our residential houses we use tank type water closet. I will tell you the difference between the water closet with flush tank and flushometer valve in the next video, but just in this video focus on the data extraction from this table, right? So the water closet with private flush tank value of is 2.2 here, right? Cold water value is 2.2. You know, everybody know the water closet only require cold water in most of the cases, right? We don't require hot water unless you live in a very cold area. So the lavatory is 0.7 fixture unit. How we get this? This is the lavatory, public or private. We are dealing with private. It means this is lavatory, private, 0.5 fixture units. Water supply fixture unit, WSFU 0.5, and 0.5 hot water. So in this case, let's suppose my client does not want to install hot water facility. So I'm only interested in calculating the cold water value 0.5. Okay. So this is how you will get the values of WSFU. Don't get confused. I will solve the project sample project that I already showed you in my previous video. I'm just telling you that how to get the values of fixture units. Now coming back, 0.7 fixture unit. So the difference in fixture unit is basically due to the fact that a toilet required more water than a sink, right? This requires more water than a sink. So therefore it has high fixture unit value. Now let's have another example. We have a public water closet, right? That was residential. Let's suppose we have an airport or a shopping mall and we have installed a water closet, tank type water closet, right? In this case, we have 5.0 fixture value. Let me show you with the help of water closet, public flush tank 5.0. So why there is a difference value of fixture unit? It has same tank, everything is same. So basically, a public water closet has water supply fixture unit value of 5.0, even though the water closet is the same as the private water closet and same amount of water required. So we can say that public water closet has a higher usage frequency, which increase the WSFU value. Okay, so that was a brief introduction about water supply fixture unit. We will use this study during our design. Okay, so in the next video I will teach you about the difference between flush of meter valve and flush tank, and then we proceed with the sample example that I already showed you in my previous video. So now we will study about the flush tank versus flush valve water closets. Let's discuss about the flush tank water closet. A tank type water closet uses normally the tank fluid elevation to forcefully flush the water closet waste through the waste system, right? And it uses, after a tank is flushed, basically it uses a fill line to refill the flush tank, right? And the fill time is approximately, you can say, 20 seconds. At a residence or residential facility, small home, this fill time is acceptable, right? But on public spaces, it is not acceptable because the frequency of use is more in public areas. This is a picture, schematic diagram of a flush tank water closet for better understanding. Now, if you look at the flush valve water closet, we have this image. This is without a tank and a flush lever over here. When you push this lever, with the high pressure fluid or water will come through this pipe and it remove the human waste from this toilet or water closet. In this type flush valve water closet, it usually used in public spaces like airports, shopping malls, etc. And it has high pressure. So now go back towards this load value sign fixture table. Water closet, we have water closet public, flushometer valve 10, flushometer valve 6. So there is the difference between, I already teach you the difference between tank and flushometer valve. Flushometer valve or flush valve is same.